Today, we will get started with OpenInsight by creating a workflow that automatically classifies points with X and Y coordinates ranging from 0 to 1 into 4 groups. First, go to the project list page and click the Create button to create a new project. Make sure the project name does not overlap with any existing project names. After creating the project, scroll down and click the Workflow button in the created project. On the Workflow Design page, you will initially see a request chip and a response chip. The request chip defines the input parameters received from an external API call, and the response chip defines the output result to an external API call. In this example, we will register to nodes in the request chip. X node corresponding to the x-axis, Y node corresponding to the y-axis. Select the request chip, right-click, and choose Show Properties. Then go to the Nodes tab, click Add New Node, and enter X as the name. Repeat the process to add another node named Y. Next, find the K-means classifier chip and drag it onto the design canvas. On the K-means classifier chip, right-click and choose Show Properties. In this K-means classifier chip, set the cluster count to 4. Then, in the Input Node Registration screen, add the X and Y nodes. If you want to reuse the node names already created in the request chip, you can select the request chip, right-click, and choose Show Properties. And select nodes you want copy its names and click Copy Selected Node. Then, in the K-means classifier chip's input node screen, click Paste Copied Node to insert the copied nodes. Next, connect the request chip to the K-means classifier chip by dragging a wire between them. Right-click the wire and select Show Properties. In the Node From field, select the node to connect. If the names of the nodes in Node To and Node From match, you can simply click Auto Wire to automatically connect them. Now, let's enter sample data and execute the workflow. Select the request chip, go to the data table below, and click Add to manually enter values between 0 and 1. Right-click on the request chip and choose Execute to run it. Then also right-click on the K-means classifier chip and select Execute. At this point, you will see an error message because the K-means classifier must go through a fitting process before execution. Select the K-means classifier chip, right-click, and choose Fit. In the Training Data Input screen, click Import CSV and select the CSV file to use for training. Then click Fit. After reviewing the fitting results, click Complete. Now that training is complete, execute the K-means classifier chip again. Next, for additional testing, find the Generate chip, drag it into the design area, right-click it, and select Show Properties. Set Generate Count to 1000 and add to new nodes named X and Y. Right-click on the Generate chip and click Execute to generate 1000 data points. Disconnect the connection from the existing request chip and connect the Generate chip to the K-means classifier chip instead. Now right-click on the K-means classifier chip again and select Execute. You will see the classification results for the 1000 generated data points. Now let's delete Generate chip by Delete key on your keyboard and rearrange other chips. Next, to send the classified result through the API, select the response chip, right-click, and choose Show Properties. Click Add New Node and name it Class. Connect it to the K-means classifier chip, right-click on the wire, and click Auto Wire to link the nodes. Execute K-means classifier chip again and execute response chip for checking the result. Finally, let's deploy the completed workflow as a prototype. Click Save, then click Build. Choose Private to create a private external prototype or Public for a public accessible one. Enter the required information and click OK. The prototype will be created and deployed. You can check the deployed prototype on the prototype page. That's all for today. Thank you.